Hi, my name is Fernando Topete, and the technology I chose to talk about is the telescope. Recently, I've been figuring out what technologies really interest me and what gets my undivided attention. Um, Something that I found really remarkable and that gave me a lot of interest was the technologies of space equipment, and how amazing it is, and where we are now, and how far we've come as human civilization. So I traced it down and um, dig deep and found more of the history of where the telescope comes from, and if the telescope was the first thing or the first type of equipment used to view any stars, galaxies, planets, and anything um, interstellar, right? We can say that the telescope is a tool that I consider fascinating, like mentioned before, and um, the history kind of goes on a trend where it starts off really good and then it goes at highs and lows, and it repeats itself. So a lot of the reasons and the purpose behind it, why the telescope was made, um, it still turns around and goes to the same answer that we're seeking. Right? And that kind of ties in, and if you look at it as a value proposition, as a why we're exploring outer space. Um, some of the customer jobs, pains, and gains with this technology associated vary um, within the innovation of the same product. So, so some jobs would be, you know, they can't get to the right uh, glass of or the glass material that goes in the scope, or um, actually that would be more closely related to a pain. So one of their jobs would be more primarily um, trying to see into interstellar um, avenues, and their pain would be not being able to see through a clear glass. Some of the gains they get is study what is out there, and then honestly to find out the most common question: um, what is really out there, right? Uh, and why the telescope? Well, the answer is very easy. Why not? Like I mentioned before, it has a grand history of innovation. Um, so, what was the first telescope? And what are we seeking, right? Ever wonder what is out there? Well, the history of the telescope starts with the naked eyes. That was the original thing we used um, back in the early days. Early peoples, the nomads and tribals, Egyptians, the Celts, and the Mayans, and others that other astrologers that used to view out into space. The first tool, um, the Greeks. So the ancient Greeks learned to make a precise instrument, and it was crowned in genius. Uh, it's called astrolabe. The handheld device had a movable arm, right there, the little leverage, um, to measure angle of the right bright star in the horizon. So, in other words, measuring the star's altitude. Um, the metal map that stars mapping grades like the little engravings there, um, were to determine the time, direction, and locate the stars in the sky, to determine where the sun would rise and set also. And it would make other calculations too, like standard configurations um, and whatnot. And this was first developed by, first or second is still really unknown um, by the or near the Egyptian city of Alexandria. So another example um, is the observatories. This was introduced by the Islamic astronomers. Um, it basically made careful observations to improve planetary and stellar position. So the the observatories, um, they were everywhere. I mean, they were in China, they were in Spain, San Mark, and they were mostly all built around 1420. So it was a couple of years after 1259, as I put on the slide. They were more accurate. They measured the position of the planets. The princes reported such work because of the patronage art and the science reflected upon their glory themselves. So basically, anyone with higher authority would clear this because they looked at it as a genuine science to find out more information about space. The quadrant, this basically the sighting of the stars, is one of the earliest devices. It's considered a crude stick. It basically marked off in degrees. It had an arm right there, like 2, where it measured the star's altitude, similar to the astrolabe. It also had a double-laid mirror, and it had an inseparable companion, so that the navigator and the electrical positioning of the system in the late 20th century would be able to help with the position of the stars and the planets. Okay. Let's go to the next one. This one's really, really cool too. The armillary sphere. This was by a Danish astronomer. The name is Tycho Brahe in the late 1500s. Basically, what it was used is to study the sky and teach about the celestial coordinate system. So it helped locate objects in the sky. They were composed of rings, the rings that are layered, and they represented great circles of celestial sphere. So it helped with to detect objects and differentiate the positioning of 2 objects. The Great Mural Quadrant, similar to the other one, this one established in Europe in the 16th century. So what this one had, it would observe far right slides of sight device line up with the star, and it would see through the opposite wall. So what this one was in charge of is basically an instrument that would precisely measure just angles. The wall, like you can see there, was a 90-degree arc attached to the north and south wall with sighting to measure the altitudes of the stars and planets. So kind of like the regular quadrant, just at a bigger scale. And then came the invention. So finally we get to the scopes. Here's a slight sketch made by Giambattista della Porte. In a letter he wrote in 1609. So then Galileo has octave tube, you can see on the right, and he's actually on the next slide. In the summer of 1609, after the patent application went through in 1608, this was one of Europe's first scopes to actually hit the market. Okay, and then let's go to the next one. Well, real quick, just on Galileo, the first telescope was basically a tube containing 2 lenses. His first attempt was a 3-power instrument, but to magnify objects approximately 9 times. So it wasn't that powerful, but it was worth it because they would use it as a commercial use, or he thought about the military. Okay. Oh, here's Johannes Kepler. So kind of going off of what Galileo had incentivized about doing a 2-lens approach, because obviously the tube shows only 1, right? So we call it the upgrade, because in 1611 the convex lenses arrived. So this was basically something that wasn't recognized until 1630, just because one, it was two lenses, and two, when you viewed up to the sky, everything was upside down. So in early reflectors, we'll start off with James Gregory because he was one of the originators for this type of innovation as far as the scopes go. He proposed a new design for a reflecting telescope, but the thing with this is that it concluded that the refracting telescope would always be defective. This was actually based on what Isaac Newton discovered, and he's the one with the conclusion. He said that the lens would be like prism and disperse the colors of light in direct proportion of refraction. So the result was chromatic aberration. So in other words, the image of like a white star would always look or show like it's smeared. So what Newton did is turned his attention to a design that on a practical telescope that would use a mirror to collect the starlight. So the same design, just a different type of, I guess, innovation within the same scope. Okay, let's see. So just like Newton, we have John Hadley and William Herschel. So these guys played a very important role when it came to the refinement of the early reflecting telescope, because what they did is it basically incorporated what Newton had his original idea and took it to magnitude. So Hadley's first scope, the reflector, obviously increased in size, and it just encouraged by his success. Herschel's 20-foot telescope had nearly 19 inches of diameter, encased in a tube of 20 feet long. Mirrors, or telescope mirrors, that were made of mostly metal, copper, and tin, so that they can magnify, and this is unknown, but they say up to 200 times, which at the time was a significant amount of magnification. And the golden era of refractors. Here's what we were talking about earlier about chromatic aberration. So touching base again on chromatic aberration. So this was a new discovery, kind of what we talked about earlier, how biconvex lens receiving parallel rays of white light, where they also focus for blue rays, focus for yellow rays, and focus for red rays. But the thing is that since looked at it before, it was considered debunked, I would say, because it was looked at as something that would smudge on the opticals or the glass. So there was a high demand for glass makers to perfect and manufacture the high quality optical glass, so that opticians figured out a way that the smearing colors by the lenses would partially diminish, and the glass in particular had to be exquisite free of defects and residual color and impurities. And furthermore, Pierre-Louis Grenade, he was a German optical firm owner. So what he did is pass the secret of making the right optics to Joseph Fraunhofer, so that he could further examine the dark lines that mark the spectra of the light of the stars. So he continued to experiment with glass making and lens design. So in 1825, President John Quincy Adams was complaining that while European nations could boast of having over 130 lighthouses of the sky, that America only had a few observing facilities in private hands. So by the end of the century, this was remedied, and Americans financed tremendous surge to do some telescope building. So that's why it's known as the biggest commission. spectroscopy and the birth of astrophysics. So there was an unexpected discovery. In 1835, Auguste Comte, uh, a French philosopher, stated that humans would never be able to understand the chemical composition of the stars, and well, he was proven wrong. Later in the half of the 19th century, um, the later astronomers began to embrace the new techniques, and spectroscopy, spectroscopy, and photography were unexpected discoveries. So they were picturing cosmos, and that was one of the 1889 major advances. Um, there were some new tools of the new astronomy for picturing. So this is what helped uh, view what the sun or the light or the mid spectral line of the hydrogen, um, and it would reveal the features of the atmosphere of its ordinary star. Um, and this was kind of like the rebirth of the reflector, going back a couple slides. So in 1903, there was an astronomy mount in Wilson. This is actually off of Pasadena, California. So it was on a mount where it would oversee also Los Angeles. So George Elliott Hale um, would scale these basically bulbs um, of glass to get to reflect the light from that was coming in from space. Um, see, and what are the new tools? Well, one of the new ones is the electromagnetic spectrum, and it's basically shown down here where you get to name. We get to understand what waves are. So we got radio waves, and we can measure them and their lengths. We got microwaves, infrared, uh, visible light. That's kind of going back to with the electromagnetic spectrum, ultraviolet, X-rays, and gamma rays. So our noisy galaxy. So that's another thing too. That with these telescopes, that we're able to detect sound. So that's where radio astronomy came into play in the development of that. And that was part of the discovery of Riccardo Giacconi. And then the COBE in 1989, COBE was actually, or Kobe, was this this tool or device, this telescope sent out to outer space to be able to see even further than what we can see down here on Earth, and try to engage in communication. So from that history, there's obviously more to it, but what brought me to this point, a little bit of history, is that this recent, as of yesterday, there was this live seminar that Jerry Milner, a multi-billionaire, Russian billionaire and entrepreneur, is funding Stephen Hawking's breakthrough initiative that is to investigate to investigate intelligence in life organisms, whether it's outer space, and also not or to be able to communicate at a much larger distance. So what Jerry Miller is he's funding $100 million for the next 10 years for research into what they're trying to do is bring all the scopes together and keep it open to the public so that we are able to access what we would have access to in a year worth of sound, and we would be able to listen to it and analyze it within a matter of an hour. So that's pretty significant. And we're trying to see if there's interterrestrial life. So when we look at what is the full accomplishment or the valid proposition, if you look back all the way to the beginning of the slides, I think this is a common theme. We were always on the urge to discover what else is out there, and why or how we came about, because um, we know about the whereabouts of other living organisms, but we don't know where human, or if there is any other human intelligence out there in living organisms in space. So I find this very interesting. I would also, if you have any questions, I can post the link to the seminar. It's like an hour and a half long, but it's very interesting, and it goes more further into detail of the history behind all of the reasonings and the whys of the telescope, and what tools are using, and how it's going to advance, and whatnot. Well, thank you for listening.